Okay, so from the last time, I have some improvements in my code that I will be talking about right now. And the way I want to approach this is I will show you the entire workflow while I'm doing it, and I will explain you how I'm doing it and what my code is doing in the background. Okay, so this is my add new device um, page. So for testing purposes, I have a testing device. If you can see here, this collab test R8 and R9, and I have created this topology. It's just two routers connected to each other. That's it. Just for um, the demo purposes. So I have R8 and R9, and what I'm going to do is I will create a new device configuration. Let's say R8, and I'm gonna select the router type as access. And in the previous videos, I've shown how each of these form fields work, and I am not going to populate any of these fields. But before I actually click on submit here, I want to show a couple of things here. I'm just logging into R8, and this is the running config here. As you can see, this is the bare minimum configuration. It's this username and host names and I think SSH configurations, but there is no interface configurations. So for this example's sake, I would just configure one interface, let's say Ethernet 1 with an IP address, which is pretty random. Okay, and this is the only configuration I'm putting in for now. Now, once I click on submit, this code does three things. One, it saves whatever this configuration is generated on the front end to the generated into this directory called generated configs. It's empty right now because I haven't generated any configurations. But once I click on submit, it's gonna have a YAML file which is saved under this directory. Second, once this file gets saved on this directory, it pushes it to my GitHub repository, which is here. You won't see the generated config directory here because it's empty. Third, it will trigger a Jenkins job right here, and I will just remove all the build history, and you can see there is no build history. But the third thing that it does is once it gets pushed to GitHub, since I have a GitHub webhook configured, it will trigger a Jenkins job, and you will see it here. So let's see how this works. I'm going to click on submit. And if you see, it creates an R8 access.yaml. And the second thing that it does is it pushes to GitHub. As you can see, it creates a generated configs directory, and under which I see R8 access.yaml with interfaces, Ethernet, IP, configuration. This is the only config that I kept. The other things are just blank. And now if you go back to Jenkins, you can see that it triggers a Jenkins build. Now let's see the console output. Okay, here's the place where I'm going to talk about all the unit tests that I do in my Jenkins file. So the first thing that let's actually see the pipeline overview because it's much easier to read it from this place. Okay, so if you can see here, the first thing that it does is it checks out SEM, which is it just does a git pull so that it has the latest configuration. The next thing that it does is check out code, which we can ignore, but this part is what I want to talk about. Install J2Lint. As mentioned previously, I'm using J2Lint. It's just like PyLint, but for Jinja 2 templates. It checks for any syntax errors in Jinja 2 templates. And from the previous videos, I've mentioned that I have multiple Jinja 2 templates here. for access core, edge, then I have for OSPF, ref, static routes, etc. So it's just running a J2 lint on uh, all of these Ginger 2 templates. So the first thing that it does is it installs J2 lint if it's all if it's not already installed. The second one is it lints Ginger 2 templates. It checks all the syntax errors and reports success or failure based on if there are any errors or not. The next thing that it does is it verifies if a generated config file exists in this directory, which is generated configs. As you can see, r8 access.yaml got created after I clicked on submit. So if you see here, it just checks if this YAML file exists under this directory or not. The last thing that it does is it does a ping test, checking if R8 in this case is pingable or not. Okay, now let's go back to the console output. Okay, if you see here, it first checked out, it did a git pull and it's seeing if it is in the latest version or not. Okay, and the next thing that it does is it does install J2 lint. Since I already have it installed, it says requirement already satisfied. Then it does a lint on all the Ginger 2 templates. As you can see, it's access.j2, bgp.j2, and so on and so forth. The third stage that it does is it is verifying if the generated config exists or not. If you see here, the command that I'm doing is just a simple ls on generated configs, and it's just checking if this particular YAML file is exists or not. And it says, hey, this exists, so successful. And the last thing that it does is a ping test. So if you see here, it's just pinging R8. And if you see here, it's pingable and it says R8 is pingable. And so it says Jenkins job is successful, no errors found, and finished is success. And that's how I'm doing all the unit tests. Now let's go back to our front end. And if you see here, it says the Jenkins job completed successfully. You can now proceed to push the configuration. And if you see here, if you would have noticed in the previous videos that the push config is by default disabled until and unless the Jenkins job doesn't complete successfully, it is just disabled. But since it's successful, it has been activated. Okay, now comes the third part. What happens after I click on push config? It does three things. The first one is it generates the actual running configuration from the YAML file, which is here. So we have this YAML file, which is r8access.yaml with some parameters, but it still doesn't have a running config file. So once I click on push config, it will generate a .cfg file, which is the running config for R8. That's the first thing. The second thing that it does is it will push the .cfg file onto the device. And the third thing that it does is once it's successfully pushed, it will delete both the CFG file and this YAML file. Now let's see it in action. I'm gonna open a new tab and SSH to R8, and let's see show run in Ethernet 1 because that's one interface that we configured. As you can see, there is no configuration now. Let's click on push config, and if you see here, okay, that was pretty quick, so you couldn't, I wasn't able to see the r8.cfg file, but if you see here, it has configured the IP address. So essentially what it did was it created the .cfg file, but since there were very less configuration, it was quick enough to push the config and just delete both the files. As you can see, it had R8 access. Now it's no longer there. And so that's how it just pushes the configuration. The second build that happens is it's this you can just ignore for now, because once it actually deletes it, it just pushes it to my GitHub repository, and that's why uh, it just triggers another Jenkins job. And actually, this is a good use case to show. So I'll show you why it failed. As you can see here, there is nothing in the generated configs directory. And if you see here, the J2Lint is installed. J2Lint says it's successful, but this is where the error occurs. It says that generated configs, there's no file in this folder. No configuration file found in this directory, and that's why it failed. So that kind of confirms that it checks if there is any configuration directory, any config in this directory or not. And that's why you will see this error in the front end. It just says Jenkins job failed. Okay, so that was about um, how my entire code works. Now for the second objective, I have a script called nethealth.py, and it is essentially doing three things. One is it's extracting the CPU usage. The second thing is it's just seeing if the OSPF neighbors are up or not. And the third thing is it is checking BGP neighborship right here. Okay, this is where I'm checking all the. Okay, I will execute this to show you how it works. Okay, and I can just click on any of these devices, let's say R1, and it's just checking a health check on R1. And if you see here, it says CPU usage is 4%, OSPF neighborship states, BGP is inactive for R1, that's why it just says BGP is inactive. This is the route table, this is the IP connectivity, and so on and so forth. Obviously, I can just check for R3 and it's gonna do the same thing. As you can see, for R3 there is BGP neighborship, so that's why you will see a BGP neighbor here. And I'm just gonna quit the CLI tool. Okay, so for coverage, I have another Python script which is a unit test, which is called test_netman.py. And what it essentially does is it's just checking each and everything like CPU usage, OSPF neighbors, and BGP neighbors, and it is calling from nethealth.py. It's importing that module in this, and it's just checking if the BGP neighbors are up or not. Okay, now I have a tool in Python called coverage. If you see here, this basically checks the coverage of the overall coverage of the code and how much of the code is covered. So to run this, um, this is how I run it. It just is coverage run source test netman, which is my unit test. And if I just run it, it'll give me something like X amount of tests have run. Yep, it says that I ran 9 tests. Now to see a report, I can just do coverage report -m. and it says 100% of the code was covered and there were no missing statements, and these are the total number of statements that it covered, which is 25. I can also see it in website. So if I just open this and I do index.html, as you can see, it says coverage report is 100% and it's running testnetman.py. And if you see all the functions, it's checking the setup. It says it's 100% covered. OSPF neighbors, it's 100% covered. BGP is 100% covered. So yeah, that's how I am doing coverage. And that's all.